All right, welcome to Pomodoro Joe for Thursday, September 7th, 2023. Today we're doing LeetCode problem 92, reverse linked list 2. This is a medium problem. Given the head of a singly linked list and two integers, left and right, where left is less than or equal to right, reverse the nodes of the list from position left to position right and return the reversed list. All right, so it looks like we've got an example here. Now I just want to see if left and right are within 0 or within 1 to something. And it looks like it's 1. So our nodes are going to be 1 indexed, not 0 indexed. So in this example here, we have left is 2 and right is 4. So this is 1, this is 2, 3, 4, and 5. So we reverse from 2, 3 to 4. All right. So we'll put 25 minutes on the Pomodoro timer and we will get started. I'm going to break this down into some sub-problems. Now this won't be the most efficient or the most code compact way of doing it, but I think it illustrates how to solve the problem. So let's break this down into sub-problems. First problem, let's find the node where we need to start our reversal. So that's problem number 1. Let's find this left node. And then problem number 2, let's find the node that ends our reversal, the node at this right here. And then problem number 3 is actually doing the reversal itself. Okay, so let's go ahead and find that first node. So let's see, we'll have some node, we'll set it equal to head. And then we need to keep a count because we're going to find this node at this left index, and we need to find the node at the right index. So we need to have some count here. And we're going to start it at 1 because, as we saw here, this is a 1-indexed list. Next, we'll need to go through our list and then I need to find a good name for these. Well, let's just go through our list. So while we have some node, so our node will become the node.next, and our count will go up by 1. All right. Now, when our count is equal to left, then we're going to do something. And when our count is equal to right, we'll do something else. So if count is equal to left, well then, for now I'll pass, but this is where we found our node that's this left starting point. If node is equal to right, again, I'll just pass for now, but that means we've found the node that is our ending point of the reversal. So maybe I'll keep some variables out here, like a reversal start node and a reversal end node or something like that. So I'll have a start node, set it to none. We'll have an end node. We'll set that to none. All right, so here, our start node is the node that we just found. So start node is going to equal this node. And here, the end node is going to equal this node. Cool. So we found the start and end nodes of our reversal range. Next, we actually have to do the reversal. Now, a couple things. I just noticed we could probably actually early out of this. We don't need to traverse our entire list. We could actually end the list as soon as we find this. That's an optimization that we'll do later. For now, we'll just go through the entire list. Cool. So now that we've found our start node and end node, how do we do the reversal? Well, this is actually where it gets a little bit tricky. Let's just make a helper function. Let's do that up here. Call it reverse, and we'll call it segment. All right, and for now, I'll just pass. Okay, so what pieces do we need to know to reverse our segment? Well, we definitely need to know our start node and our end node, but we also need to know what node came before the start node, because we actually need to disconnect that node and reconnect it to the new start. So we need to have like the pre-start node. And then at the end node, we actually do need to know what node comes after this node so that we can actually reconnect our new end node to the rest of the list. So I kind of need a post-end node. This is more information than we actually got out of our traversal here. So we need to know the node that comes before our start, the node that comes before the reversal, so we can reconnect that afterwards. We need to know the node that comes after our reversal, so we can reconnect that afterwards. And then we need to know our nodes in between. Oh man. So To get our node that comes before this start node, when we go through this traversal, we'll actually have to keep track of the node that's before our count. So we'll need our previous node. So let's have a previous node here. All right, so now we're going through, as we advance our node, our previous node becomes this node, and then we advance to the next node. Cool. So when we get to this start node is equal to node, that means our previous start, or our pre-start node, that's equal to this previous node. All right, now I don't have this out here, so let's create that. Then when we get to the right node, the next node is actually our post-end node. So we can just do this here. Our post-end node, well, that's this node's next node. Cool. And I actually need to have that out here. Post-end node, set it to none. So now we have the 4 pieces that we'll need to do our reversal. So we found our reversal pieces, then we'll call the reverse segment. Then we'll have to return, let's see, what do we return? Well, we might have a new head to our list if we happen to be reversing nodes starting from the head. So we might actually have a new head here. Nuts. That means this reversal might need to return something. I generally don't like doing things like this where you'll return some new list only sometimes. I don't know. In this case, I'll make an exception though. So we'll return the new list head. Now, that's if there is a new list head. Okay, so we'll return the new list head. We'll just have to remember though, if this pre-start node is none, meaning we are starting at the head itself, then we'll have to use this new head as our return value. Otherwise, we'll return just our regular head. Okay, so we'll have some new head. That's going to equal our reverse segment. And we'll pass in all these pieces. Actually, I think I just called it this, so I can grab these. All right, and now we'll return this new head. But that's only if this pre-start node was none. Otherwise, we return our existing head. All right, so that's a little bit tricky. This pre-start node is just saying this is what comes before the start of our reverse segment. Now, if there is nothing before our reverse segment, that means we're reversing from the head of our list. And so that means that whatever we've reversed to, the tail of our reversal, this end node, that becomes the new head. But if we do have some start node here, some pre-start node, that means our list head is intact, it doesn't change, so we'll just return the head. Okay, so I think this will work, it's just a little bit complicated. Now, the reverse segment. Okay, we need to go through, reverse all the nodes between the start node and the end node, and then we need to reconnect those nodes to our pre-start and our post-end nodes. Okay, first thing I want to do, pre-start node, if we have one. Actually, let's check that here. If we have a pre-start node, so this is the node that comes before our reversal, I'm going to disconnect it. I don't want to have anything left over. I don't want to have any lingering pointers here. So I'm just going to disconnect it. So our pre-start node next is none. So we've disconnected the first half of our list, or the first segment of our list, from this reversal part. Next, I want to disconnect the end of our reversal part, this end node, from the rest of our list. So our end node dot next is none. Okay, so now we've successfully severed this middle section, everything from the start node to the end node. We've disconnected them from our list and removed those pointers. So the thing that led to the start node, we've disconnected, and the thing that leads to the rest of the list from the end, we've disconnected. So now we have sort of 3 segments to our list. We've got everything that comes before this start node in one segment. We have the start node to the end node in another segment, and then we have everything that comes after the end node all the way to the end of the list in our third segment. Now that we've successfully sort of extracted this piece of our list, we can go through, flip all of our pointers, so we reverse all the nodes, and then we'll have to reconnect the new list after we're done with that. So we'll have some node. We'll start it at our start node here. And let's see. I guess while we have this node, we'll need to keep track of our previous node just as we did before. So the previous node is none. And while we have our node, so we'll just go through and we'll flip all of our nodes around. So this nodes.next will equal the previous node. Oh, but I don't want to lose my next node here. So I'll have some temp node that's going to hold on to node.next. So we're going to look ahead, say that node is supposed to come next. We'll just store that in our temp node. Then we'll actually sever that tie. So our next node for this node's next will now point backward the other direction to our previous node. Then we do need to update our previous node. It's going to be equal to this node. And then this node will equal node or temp node. So we move on to the next node. All right, and I need to have while node. Cool. So this will successfully flip all of our pointers around and reverse our list. Now we need to reconnect this list to the rest of our list. So let's see, if we had a pre-start node, now we'll reconnect the pre-start node to our new list head. So pre-start node dot next, and that will equal, and this is kind of weird, but this is true, this will equal our end node. Because we've flipped everything around, our end node now becomes the head of this new segment. So our pre-start node's next will equal the end node. And then we need to reconnect our end node, which is now the start node. So now our start node dot next, and that's going to equal our post end node. And then we will return our new start, and that's going to be, let's see, that's going to be the end node. So this is the start of our new segment. Now, of course, this might not be the start of our new list. We only check that down here. Now we could check it inside here. We could maybe return none if we don't have a new head, and then return the new head if we do have a new head. That might be better. Well, let's just see if this works. So we've broken our code down into two subproblems. First subproblem, find where our reversal begins and ends. And then the second subproblem is just reversing that segment from the start to the end of our reversals. And then we do return our new head at the end. Let's run this. I probably have a ton of typos, but let's see how we do. All right, and then type object has no attribute next. Where is that? So it looks like my end node is none, which means I got something wrong in here. All right, this should be count. Well, the count. Okay. Let's see what else I messed up. Oh, that might have been the only mess up. Really? Okay, let's submit this and see if we can pass all the tests. Oh, wow, look at that. And we pass. We don't do great though. We only beat 33% for runtime. Actually, that might be 33, yeah. 33% for runtime, 31% for memory, so not the best solution. Now, there are definitely more compact ways to do this and probably less confusing ways. So I mostly did this as a way to explain how to do it. Now let's see what else we could do to maybe speed this up. So let's see, most of this is pretty straightforward. Well, we could try that thing while node and count is less than or equal to right. And then we break out as soon as we get to right. That's one thing we could try. See if this saves us anything. It means that we don't have to traverse the entire list. Oh wow, that makes a big difference. Now we're at 73% for runtime and 51% for memory. Oh no, 91% from memory. What? Okay, so that makes a huge difference, just jumping out of this as soon as we found our right node there. We don't need to traverse the rest of the list. Well, I think that's probably a good place to end it. All right, so for this one, we had to reverse a segment of a linked list from some start node to some end node that were given to us by the index or the placement they exist in the list. So we went through, we found those nodes where it starts and where it ends. We also found the nodes that came before the start node and the node that comes after the end node. So then we could pass that to a helper function that will go through, reverse all the nodes from the start node to the end node, and then reconnect them to the node that came before and the node that comes after. So in the very end, we return the head of our list. If we had a new head, we return the new head. Otherwise, we return the head of our existing list. All right, well, that is it for me. Hope you had fun. Hope you learned something. Hope you can go out and write better code.